Today we're going to learn about Pi0 model, innovative robot AI model, which is the VLA model, Vision Language Action model. It takes the inputs as a command and an image and take a output as the action. So after understanding of instruction and image, they move, it acts. Let's look at the structure of the Pi0 here. It takes the input as an instruction and image, and there's the two main part, VLM model and the action expert, and the output will be 50 action chunk, so it will be continuously, it will move, not like move once after one inference. So let's look at the input here again. Here's the instruction, which is the sentence. Just like, for example, pick an apple. We tokenize it, which means change it into the vector so the computer can understand, and we do the same thing with the image. We use the vision transformer here. When you learn about transformer, you learn CLS token. CLS token is random value at the first time, but after those attentions and a transform block, it includes all the meaning of the input, the whole image. So we put the instruction tokens and one CLS token into the seek leaf, and we will get the QKV value. In the normal LLM model, they will de-tokenize them and make the sentence like a ChatGPT, but we're going to just put stuff here. And let's look at the action expert part. It's also used the Gemma transformer model and flow matching. We're going to talk about this later. Its input is the QT, which is the robot's current state, and put the noise 80 tau. Sorry, this is the T, and the output will be, yeah, the 50 action vectors. Let's look at the noise here. The 80 tau is the theta epsilon, the tau plus 1 minus tau AT. This is noise, and this is the original action vector. So let's look at the inside. The epsilon is the noise itself, so it follows the normal distribution, Gaussian noise distribution, and tau is how much noise we're going to put. So let's put the 0 to this tau. This will be 0, epsilon times 0 will be 0, and plus 1 minus 0 AT will be AT, which is the original action, the vector. So when the tau gets bigger, there will be more noise added. And let's differentiate the AT tau. When we differentiate something, we will get its velocity, which includes the direction. So the formula is really easy. The d tau AT tau will be epsilon minus 18, easy, and we called it u theta, which is the answer vector. It will be compared with the v theta, which is the inferenced by vector by the neural network. So the inferenced vector by neural network, which is the random in the first time, can be somewhere like here, and the u theta, which is the answer vector, can be here. But by differentiate if we know the direction, we can continuously move to make it closer to the answer vector. So we put the MSE lows as this u theta minus v theta square, and then with the backpropagation and updating the weight, we can train the v theta. So we're going to use v theta at the inference, because we do not know about the u theta, which is the answer vector at the inference. At inference time, we generate actions by integrating the learned vector field from tau equals 0 to tau equals to 1. Here's an ODE, and we use the Ford Euler integration rule. Well, the delta is the integration step size. We use 10 integration steps, which is delta equals to 0.1. So if the delta is 0.25, there will be 4 steps, and if the delta is 0.5, there will be only 2 steps, and the inference will be more inaccurate. So here's the formula, and let's look at the attention. There are 3 blocks, block 1 and block 2 and block 3, and we're gonna do masking. You may have heard of it in transformer. That's that we do not allow the tokens, current tokens, to see future token, because in the inference we cannot see the future token. They are waiting for our prompt in ChatGPT, for example, and so we do not allow block 1 to see block 2 or 3, and we do not allow block 2 to see block 3, while the block 2 can see block 1 and block 2, but block 3 can see block 1 and 2 and 3. So in the transformer block, the decay root times or the qk t plus m. The m is the masked matrix. So here's the value like minus infinite, because at the end there's the softmax, so it makes the relevance between the blocks to 0. Because when the image and instructions getting in, they cannot see current state and noise action on the training, and like saying current, and when the current state getting in, they cannot see noise action. So that's why. And the last thing to tell you is the QKV from VLM and Action Expert has the same dimension, so we can put them into the same space, and we will finally have to wait from VLM and wait from Action Expert, but the wait from VLM will be frozen because it's already well trained, because we use just the well-made Gemma model, and we're gonna only update the weight from the Action Expert because that's where it makes the robot outputs. Yeah.